Hey physics peeps, today we're going to talk about momentum, what it is, how we actually calculate it, and other things that you need to know. And actually before we get into momentum, we need to talk about speed and velocity. Many times we use these terms interchangeably. There is a slight difference between them. And if you remember when we talked about velocity, really it's a speed that has direction to it. And whether we're talking about speed or velocity in these cases, that direction has an effect on the number that we use for speed. Like when something's going to the right, we say that it has a positive speed or a positive velocity. When things are going to the left, it's a negative velocity or negative speed. So when we look at examples, we'll use that. So if someone throws a ball at with a speed of 30 meters per second, which is really fast, and it's to the right, it's a positive 30 meters per second. But if this person is then moving backwards because they threw it, and they're moving at 5 meters per second, because they're going to the left, we would say that their speed is negative 5 meters per second. And that's the gist of it. But now getting into momentum. So momentum is really defined as amount of motion that something has. And it's equal to a mass multiplied by velocity. So you probably used the word momentum before, but in physics it has a very specific meaning. And it's this. It's like a mass multiplied by its velocity. There's an equation for it, and that's listed down here. And momentum, it's abbreviated with a P, and you need to know that. You recognize this equation. So when you see the P out in front, it's momentum. Why it's a P? Well, M was already used because M is used for mass. So, yep, that's it. But P is what we use for momentum. It's equal to the mass times the velocity. That's it for the equation. What you do need to pay attention to is the units as well. Mass, it's in kilograms, and it has to be in kilograms. The velocity, it's in meters per second. We're used to that. The unit for momentum, though, is kilogram meters per second, which is a weird unit. But you could actually remember that by what you do over here, because mass is in kilograms and it's multiplied by the velocity. That's in meters per second. It actually tells you what the unit for momentum is. So you need to know what the unit for momentum is, or you need to know how to find it. That's kind of it. But the more momentum an object has, the more motion that it really has. And saying that is kind of sometimes a little weird. We'll take a look at some examples. But it could mean that an object has more mass than something else, or it could mean that that object has more velocity. So if you're comparing the momentum of two things, they have the same momentum, it really could mean that they could have different masses and different velocities. It could just take the same amount of force to stop those two objects. Kind of like if you had a big player and a small player. Even though they might be going at the same speed, one might be a little harder to stop because he has a bigger mass compared to the other one. But if you were to try to think of a time when it takes the same force to stop these two players, it could be that this player, the smaller player, is running faster. And that's when we would say they would have the same momentum. Yeah. Momentum, it is different from inertia. When we talked about inertia, it's that resistance to a change in motion, the force it takes something to stop something. However, momentum really is just that amount of motion that something has. So an object that's not moving has inertia. It has a resistance to either starting or stopping, but we would say that the momentum of it is zero. because something that's not moving, it has mass, but its velocity would be 0. That would mean that everything here is 0. Or mass times velocity would end up being 0. So you can have 0 momentum as long as it's not moving. An object that is moving, we would say has inertia and it has momentum to it. And again, kind of like using examples of something that's really big and moving really slow can actually have similar momentum to something that's really small, like a bullet, that's moving really fast. So train, if you think about its momentum, has a really large mass, but might be going pretty slow. And this bullet has a really small mass compared to the train, but it's also moving very fast. So like if you think of how much momentum they carry with them, how much and how much it would take to stop these two things, it could be about the same depending on kind of how big this train is, all that kind of stuff. But that's kind of the gist of it. Actually, calculating momentum is pretty simple too. So here's 2 examples. Like there's a 100 kilogram halfback moving to the right at 4 meters per second, and then an 80 kilogram halfback moving to the left at 5 meters per second. If we were to solve for the momentum for each one of these, we could do that. If we know that we're looking for momentum, it's the mass times velocity. And we need to identify that information. Like here's the mass of that halfback. It's 100 kilograms. And the velocity is 4 meters per second. So we put that into our equation. And we have our mass, 100 kilograms, times our velocity, 4 meters per second. And we get 400 for our answer. But our units for momentum, that's kind of the other part. Remember, if you don't remember what the units for momentum are, you can really make them up. And as you make them up because of what you do over here, whatever we did with our numbers, we do the same thing to the units. So if we multiplied our numbers together, we can multiply our units. And that is what tells us our unit for momentum. It's 400 kilogram meters per second. For something like this though, if you find the momentum is mass times velocity. Again, momentum, it starts with a P. Why it's a P, it's just what they chose. But here they told you the 80 kilogram halfback. So 80 kilograms is our mass. Here's our velocity. But you do need to be careful about that because even though the velocity says it's 5 meters per second, it's not actually just 5 meters per second because this one's going to the left. And so we would say the velocity is -5. And we multiply those together and we get -400 kilogram meters per second. When you compare these two people and how much momentum they have, yep, they have different masses, they're going at different speeds, but we would say they have the same momentum. When we say this one's negative, it doesn't mean that they actually have less momentum, it just means a direction. This person has 400 units of momentum going to the right. This person has 400 units of momentum going to the left. But instead of saying left, we just say negative. And that's what you need to know. So how to calculate momentum, but you need to pay attention to these directions because it's going to play a big role in what we do later and how we use momentum to tell what's going to happen when things collide. We'll get into that stuff next week, but you guys have a wonderful day. I'll see you later.